Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1498. Number of subsequences that satisfy the given sum condition. Let's read the problem statement first. You are given an array of integers nums and an integer target. We have to return the number of non-empty subsequences of nums such that the sum of the minimum and maximum element on it is less or equal to target. Since the answer may be too large, we have to return it modulo 10 to the power 9 plus 7, and these are the constant size nums dot length from 1 to 10 to the power 5, nums of I value from 1 to 10 to the power 6, and target value from 1 to 10 to the power 6. All right. Okay, so now see this example number 1. So this is my nums array 3, 5, 6 and 7, and target is 9. Okay, so here in this nums array we can form these subsequence like 3, 3, 5, 3, 5, 6 and 3, 6. So if I just pick this subsequence, so mean value is 3 and max value is also 3. So 3 plus 3 is nothing but 6, and 6 value is less than equal to 9, right? So we have to find all the subsequences where the value should be less than equal to 9. Okay, mean value plus max value in that particular subsequence. So 3, 5, mean is 3, max is 5, 3 plus 5, 8, 8 is less than equal to 9. 3, 5, 6, min and max. Okay, so we are only considering min and max only, right? We don't care about this. All right, so here in this also 3, 5, 6, 3 min and max is 6, 9 is less than equal to 9. All right, this is also good. And 3, 6, 3 min max 6, 3 plus 6 less than equal to 9. So in total 4. So total 4 subsequences are there, so 4 is the output. All right. Okay, so here this is one example, this is example number 2. Okay, so here target is 10, so 3, 3, 6, 8 is given, right? And here example number 3, here target is 12, so here total output is 61. All right, if you pick everything, right? So here what we need to do, let's suppose first let's suppose your nums array is given like this, 6, 3, 5, 7, right? I'm picking same example, 3, 5, 6, 7, just I changed the order, right? So in the problem statement it is not mentioned that array is already sorted, right? So don't just go over this example like nums. I see this example number 1, this is also sorted. Here example number 2 is also sorted, this is also sorted. Okay, I thought that they may give some example which is not sorted. All right, so in the problem statement it's not given that array is already sorted. Okay, so now let me tell you why we need to sort this, right? So here, see here on this example 3, 5, 6, right? So here if I see this, okay, if I write this subsequence like this, or if I write this particular subsequence like this 3, 5, 6, or if I write it like this 5, 3, 6, okay, there may be some other way, right? So we are just dealing with min value and max value, right? So from here min is 3, max is 6. Same way from this min is 3, max is 6, right? Same here, min is 3 and max is 6. All right, so order doesn't really matter here, right? Order doesn't really matter here, we can sort. Now what are the benefits of sorting? All right, so let's suppose if you see this particular example only 3, 5, 6, 7, right? 3, 5, 6 and 7 we have, right? This is already sorted. So now I am dealing with the min and max value, right? Min, and I have to do the addition with the max, right? Okay, so if let's suppose my min is here, okay, let's say this is my left pointer and my mean value is here, okay, this one, and I fix my right here, right? Okay, this max value, right? Max value is this at right pointer. Okay, so these are the index 0, 1, 2 and 3, right? So now here if you do this value, okay, minimum value plus this value, right? Since we are only dealing with min and max, right, and this is already sorted, so definitely I will get my min here and my max here only, right? In between these values I don't really care, right? Since I need min and max only for this particular subsequence. So here what I'm writing a subsequence which is starting from this left and ending at this right. Okay, so here if I do min, okay, min plus max, so what is the value that I'm going to get here? I will get 3 is min and max is 7. 10 is greater than my target. Okay, for this particular example target is 9, right? So this is not valid, right? So I can't choose this, right? So I can simply ignore 7, right? From here I can simply ignore 7 because 7 is never going to make any subsequence, right? Why I'm saying that? So see here, with this min and this as max, I see result is not possible. Okay, value is coming greater than target, right? So this itself is min. Okay, after that if I choose this, right, 5 and 7, this value itself is bigger than 3, so that doesn't make any sense. Okay, if I just ignore this 3 and just choose 5 here and until 7, so 5 is min and max is 7. 12 is much greater than 10, it's also right. So that simply means that I can't choose this 5, I can't start from 6, right? So here if I just use 7 only, then also it is not going to make any sense, right? If min is also 7, max is also 7, so that value is also going to be greater than target. All right, so I can simply ignore this, right? I can simply ignore this value. So this is only possible when my array is sorted, right? If my array is like this 3 5 6 7 and here is some other value, then I can't ignore this, right? So but here if my array is sorted and here we have 8 9 10, okay, so if with this result is not possible, definitely I can't form the result with these numbers also, right? Okay, so that is why sorting is important in this particular problem, and that is why we are going to do the sorting. Okay, clear this part, so we can ignore this. All right, so now let's suppose you are right, I reduce the value of right. Okay, so now my right reaches here. Okay, and we know that we have to ignore all this, right? So here also 3 7 result is not possible, so with 3 8 also result is not possible. Okay, with this 9 also result is not possible, with this 10 also result is not possible, right? 3 7 is 10, so if I choose min 3 and 8, that is 11. Okay, not possible, right? So I reduce my right value here. All right, so now we are just left with this 3 and 5 and 6. Okay, so now here uh, this is here, my left is here, let's suppose, and my right is here. Okay, example is much bigger, but I just told you that we can ignore this 7, right? Okay, so now here in this, if you see result is possible. Okay, so 3 and it is ending at 6, right? So if I choose min value from here, okay, so min value is nothing but 3 and max value is nothing but 6, right? So 3 plus 6 value is 9. 9 is less than equal to your target, right? Target is also 9, so we are good. Okay, so with this result is possible, right? So now here this is my left is at 0 and 1 and 2. Okay, so this left is fixed. Okay, this left is fixed. Okay, so here 3 to 6, okay, whatever I form, I will get value always less than equal to target. Okay, so that simply means that with the 3 6 result is possible, and in between if there is any number, if I write that, then also my result is possible, right? Okay, so it doesn't matter if I write anything beside, because array is already sorted and this is going to mean, and this last is going to be the max. Okay, so now here I'm saying that 3 is fixed. Okay, so now with this 3, okay, 3 is fixed. I have two options now. I can choose this 5 or not. I can take this 5 or I can skip this 5 with this 3. Okay, so if I take this and if I skip it, okay, that's it, right? Okay, now here also with this 6, again I have two options, right? With this 6 also I have two options. I can take this 6 or I can skip this, right? So here uh, with this 3 I can take this 6, okay, or I can skip it. That simply means that this 3, or I can take 6 here also, right? So 3 5 3 6 and 6 here. Okay, I can take this here also and 3 5 also. Okay, so these are the different options that I have, right? So what I'm saying here, with this 3, okay, I can take this 5, right, or I can not take this. Okay, right, so this is what I have. now. Okay, so now here again I have option. I can take this 6 or not. Okay, so if I don't take this 6, then I will get this first case only. Okay, if I take this case, this 6, then I will get this second case, that is here. Okay, and with this 3 also I have two options. I can take this 6 or not. Okay, so if I don't take this 6, okay, then I will get this third case, right? And if I take this 6 here with this 3, then I will get a fourth case, that is here, right? So with my 3 fixed, and here I have choices, right? So here two choices, here two choices. I can say that I have 2 power 2 choices, right? So this is 1, this is 2, and in both sides I have 2 choices. So total 4 choices. So my output is going to be this 4. All right, clear? So this is what we need to do, right? So now this is one part. Okay, when my left is fixed here. Okay, so now with this 3 we checked all the possibilities and we get 4 output. Now what I'm going to do, now I'm going to move my L forward. Okay, so with this 3 we have checked everything. So now my L is going to reach here. Okay, and my right is here only. All right, so now this 5 and 6. So with this we are going to check. So with this result is also not possible, right? Mean is this and this is max, result is not possible, right? So what I'm going to do in this case, I can ignore this 6, right? So now my right is going to come back. So my right is going to reach here, right? Okay, this is done. Now with this 5 and 5, only 5 left. So with this also result is not possible, so I can ignore this 5. So now my R is going to reach here. So my R value now is smaller than left. Okay, so I have to just end it. Okay, so in the end this 4 is going to be my output, right? So here I am calculating the powers, right? So this 2 value I can also say starting from here ending at here. So this index is 2, this is 0. So this 2 I can say my right minus left value, right? Okay, so until here only I need to get now. Okay, so this is from A to B. Okay, and until here we have let's suppose this is C point. Okay, right, this is C point. So here how you can understand, so let's suppose this total is X and this value until here A to C is K. So this is nothing but your total X minus K. Okay, this is how you find out, right? Okay, so here and until here. So until here you have something until here. So this is the part you need now. So that's why R minus L. Okay, so this is what you can say. Okay, so X is 10 centimeter, this is K is nothing but 2 centimeter. So this part from C to B is nothing but X is 10 minus 2, 8 centimeter. Okay, so much maths, let's leave it. Okay, but here we need to do R minus L only. Okay, clear? So we are calculating the two powers, right? And these two powers are depending on R minus L. So let's suppose my R is max. That simply means in this example, if I say my R is max, so 0, 1, 2, 3, that simply means 3. Okay, and L min. Okay, so this is the max value that I'm going to get of power. Okay, so 2 power 3. Okay, and here min when I'm going to get when my L and R both are at, let's suppose at same position. Okay, when L is also min, there are many cases, right? Both are at same position, 1 1 or 2 2. Okay, so then we are going to get min. All right, so 2 power 0. So 2 power 0 until 2 power 3. Now let's pre-calculate everything. Let's pre-calculate the powers. Okay, so here nums dot length is very big. Okay, so let's pre-calculate all the powers, okay, of all the indexes 0 1 2 3. Okay, so 2 power 0 I will calculate, 2 power 1, 2 power 2, 2 power 3. Okay, pre-calculate. So how I'm going to do that? So for that you can create one array. Okay, let's suppose power array, power of with 2. Okay, we have to do, right? So 2 power 0 initially it is just 1. Okay, right? Now 2 power 1, if I want to do, I can simply multiply this value with 2, I will get 2. Okay, 2 power 2 I want to calculate, I can simply take this above value and in this multiply 2, I will get 4. 2 power 3, what I can do, I can take above value 4 and in this I multiply 2, I get 8. 2 power 4, what I can do, I can take above value 8 and then multiply 2, 16, fast, right? 2 power 5, how I'm going to calculate, so I will take above value, in this I'm multiplying 2, I will get 32. Okay, so this is how I just pre-calculate the values in one power 2 array. Okay, so let's write the code, very simple, nothing complex, and there are other ways also. you can try fast exponentiation, right? This binary exponentiation, you can try that. There are many ways, right? So I will show you one simple way how we are going to solve this problem. Okay, so here what you can do, first we have to take the mode value, right? So in the problem statement it is given that answer may be very large, right? So we have to return it modulo 10 power 9 plus 7. So what I'm going to do here, I'm going to create one variable. Let's for private static, and here final int mode is equal to 10 power 9 plus 7 we have to do. So 1 1 2 3 4 5 6 7 8 and then 9. That's it. Okay, so this is done. Now you already know sorting is important for this particular problem. So arrays dot sort, here you can say nums, sorting is done. Then after that just calculate the length of your nums array. So int n is equal to nums dot length, and then we have to pre-compute the powers of 2 up to n, right? So you can create one array power 2, power with 2, right? New int, and here just give us n, and here just run simple loop for int start with 1. Okay, I is less than n, I plus plus, and here you, let's suppose we already know that 2 power 0 is always going to be 1 only, right? So power of 2 and here 0, right? This is 1 only, so that is why I'm starting from 1. And here I can just update my power of 2, power with 2 of at I. Okay, I, we have to write I is equal to, and here simple formula, power of here I value minus 1. Okay, so previous, right? If I just multiply 2 with it, and I will also take the mode side by side, right? Okay, so this is done. All right. Okay, so pre-calculate we are doing, right? All right, so here this is one way to solve this. Okay, one way, in this way we can fill. All right, and there is one more way, using fast exponentiation. You may already seen videos related to that topic also, right? So why we are doing this, this part or this, so r minus l, r is, let's suppose, very big value, very big. Okay, r minus l, let's say difference is very big, 32 let's say. Okay, very big. So are you going to write it like this, 2 into 2 into 2 into 2 until 32? Okay, this is just 32 times you are writing, but this may be very large, right? So definitely that is not possible. Okay, right? So to calculate like this, right? So we need some better solution, right? So for that purpose you can solve it using this, or you can use fast exponentiation. In that what we do, 2 power 32 now we just break it. Okay, divide it to 2 and we write it like this. Then we solve this part, 2 8 power 2 and 2. Okay, then we solve this part. Okay, you can try that. You may find some videos in my channel related to that as well, fast explanation. Okay, all right, so you can try this or using fast explanation, your choice, right? And here take a variable int left is equal to 0, right is equal to n minus 1, and here count you can set it to 0, and here you can run while left is less than equal to right. Okay, and inside this you can simply do basic check, right? If nums of left value, and in this if you add nums of right value, and if value comes out with less than equal to target, then it's very simple. Then what you need to do, then you have to update your count as count plus, and here power of 2, and here you have just pass right minus left, and here this is done. Okay, right minus left, and here just take the mode, right? Values can be very large, so we are taking mode side by side, and then only you have to operate your left. Okay, So with that index which we fixed, with that we calculate all the answers, then we are moving left plus plus. But if this value itself comes out greater than target, okay, that is nums of left plus nums of right. So if it comes bigger than target, then we can simply ignore that right. Okay, so right minus minus, and here that is it, and here you can simply return count. All right, so here return count from here. That's it. Now let's run the code and see if the encode issue will try to fix that. Okay, so here power 2I is equal to power of 2, here 2 should come right, and let's run it again. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted right, and the time complexity for this problem is going to be of n log n, basically due to sorting part that we are doing, right? And here we are just running loop n times, so of n log n plus of n, you can say. And here left to right we are moving, so here also you can say maybe of n only, right? Because you may move your left and right, okay, to all the indexes, right? So in worst case you can also say of n. So overall it is going to be of n log n due to this, right? So let's see the time complexity from here, right? So of n log n. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.